All right, this is number 2 and number 3 from the Chapter 6 practice test. The true, false, and then one that's just requires you to have good notes, number 3. All right, remember with true, false, all we have to do is find one counterexample, one occasion where it might be false, and we can call the whole statement false. So that's kind of what you're looking for here, okay? In proving a theorem indirectly, we begin by assuming that the hypothesis is false. All right, well, this statement is false. How could I make it true? If this word was not hypothesis, if it was conclusion, then it would be true. But since it's not, it's false. If you were asked, and you will be on the midterm final, to if a statement is false, cross out a word and insert a new one to make it a true statement. This is the kind of thing that you would do. But I just make this point that it's the conclusion. This true-false question has come up on a couple of chapter tests already, so we keep harping on that, so make sure that you're clear about it. B, through a point not on the line, there's exactly one line perpendicular to the line. Through a point not on the line, there's exactly one line perpendicular to the line. That is true. That you might say, well, hold it. That's supposed to be the parallel postulate because it's worded like it. But think about it. If there's a point not on the line, how many lines are there that are perpendicular to this line here? There's only one, and that's the one that is perpendicular to it, right? All right, the acute angles in a right triangle are supplementary. That is false. You know that it's really complementary. If it had been complementary instead of supplementary, it would have been a true statement. So it's false. D, if the hypotenuse and a leg of one right triangle are equal to the corresponding parts of another right triangle, the triangles are congruent. That is true. Right there, word for word. That's the HL theorem. Hypotenuse and leg. It only works in right triangles. E, in a plane, a line perpendicular to one of two parallel lines is parallel to the other. Well, this is a false statement. I'll show you why. All right, so in a plane, a line perpendicular to one of two parallel lines is parallel to the other. So is this line here parallel to that one? No. We could make it a true statement. If we made this word perpendicular, it would be true. But it doesn't say perpendicular, so it's false. And finally, number 3, complete the following theorem. An exterior angle of a triangle is equal to the sum of the remote interior angles. You know, you typically make this problem on here worth a lot of points. So you should have all your theorems written down so that you can reproduce them exactly. Unless your memory is so good that you could reproduce them word for word. So make sure you have good notes, because we typically make this worth a lot of points as kind of a gift to you. And then some people don't make good notes, so they don't get the gift. So they lose a lot of points instead of getting a lot of points for it. Don't make that mistake. See you on the next one.